Hello everyone. This study investigates the tensile strength, fracture behavior, damage mechanism, and reliability of 3D printer polylactic acid through a comprehensive experimental study. For this reason, our study is based on two series of tensile tests. The first series assesses reliability and statistical analysis using each rectangular PLA specimen printed with Flashwork 3D Pro 3D printer, each orientation 0, 45, and 19 degrees were represented by 6 samples. Then we conduct a statistical analysis using the Weibull distribution to evaluate the ultimate stress and fatigue life of the PLA samples at the three orientations. Three linear regression lines were plotted to model the relationship between crack length and residual ultimate stress, with corresponding equation derived for each orientation. As the stress level increases, the probability of survival decreases while the probability of failures rise, reflecting a consistent trend across various conditions. Also, we note that the mechanical behavior of the material depends on its orientation relative to the direction of the applied load, with zone shifts indicating better performance at 0 degrees. A second series of tensile tests was conducted on 80 samples, with 6 samples for each orientation and with various initial cracks from 3 to 10 mm. The curves show a significant decrease in the residual ultimate stress as a crack length increase, and also that samples at 0 degrees are the most resistant, while those at 19 degrees are the most damaged. The figure shows that the 3D printer samples follow a similar in 3 distinct stages of damage, regardless of their orientation. However, the critical life of fraction varies slightly depending on its orientation, indicating the effects of layer orientation on the initial strength, and also on the damage evolution of the material. As a conclusion, the study investigates the mechanical behavior of PLA specimens fabricated via fused deposition modeling, with a focus on the mechanical characterization, damage evolution, and reliability across different print orientation, indicating that the mechanical properties depend on layer orientation, as well as the initial crack reduce the material mechanical properties with static damage proportional to life fraction. Conversion adds 15% of its reliability, and also that the 19 degrees oriented specimen has faster initial damage over 0 and 45 degrees. As a solution, we propose that when the crack reaches 45% of its life fraction, the pre-cracked region is excised by reducing the specimen's width. This intervention eliminates the cracks, prevents the stress concentration at the crack tips, and enhances the material durability.